Hello, in this problem we are analyzing a quick hard brake with a bicycle, one that should allow for the front tire to stop with the shortest stopping distance. This brings up an issue sometimes people have when braking with bikes. They try to brake with the rear wheel when braking force with the front wheel should give you the safest and most effective brake. If a bicyclist doesn't brace themselves, shifting their weight away from the handlebars, lowering themselves, and trying to make their center of mass more horizontal, their momentum pushes them forward, kind of like when you're in a car without a seatbelt and you get into a crash. Your body keeps moving. Here's the diagram for this certain situation. We have a horizontal motion in the positive x for the front wheel and the rider. The rider has a weight force mg and the wheel has a normal force pointing up and a frictional force opposite of motion. We also have a deceleration of the back wheel. However, it is just being lifted, so we don't need to worry about the forces on the back wheel. So for this problem, we must consider a torque in the counterclockwise direction exerted by the force of friction, which is opposite direction of the movement. Since we want to see what value of frictional force makes net torque 0, we will see that we get this equation. Height from ground to center of mass times the force of friction is equal to the length from center of mass from behind the wheel times normal force of the wheel, which means that the force of friction is equal to mgl over h, since force normal is equal to mg. From that calculation, we get a frictional force of 304.9 newtons. Now, looking at the vector components, we will get that ma over mg is greater than L over h. For the bike not to tumble, we will see that acceleration must be less than Lg over h. So that means the max acceleration for the bike to not tumble must be Lg over h, or 4.36 meters per second squared. Thank you.